All right. Hello, everyone. Welcome, students logging in from across all the 5 boroughs. We are so excited to bring you to this session today. My name is Jessica Kemper. I work for the Department of Ed, and I'm joined with some awesome colleagues who will be serving as panelists today. This is going to be a great opportunity for you to learn more about the tech landscape in New York City, what kind of opportunities are available to high school graduates and college graduates. And I can say that there's so many things to learn about technology, and we're so excited to kind of give you a little sneak peek on that today. This event is part of an overall series event that the Department of Ed is doing called the Career Exploration Month. This actually is the last session of this month. And if my colleague could put in the chat box our YouTube channel, we've got all of the other sessions recorded and available for you to watch online. So if you're interested in learning about automotive careers, healthcare careers, construction careers, eating careers, or all kinds of different videos up there for you to check out. I also acknowledge that this is Black History Month. We're finishing up Black History Month, and it's always really important for us to recognize that many Black leaders in technology have been overlooked by history books over the years. And so there are occasions like this where it's really important for us to remind our students to look back at history and understand the contributions that folks like Mary Jackson and Granville Woods and current leaders like Jackie Wright are contributing to this field, in addition to other people of color. So we encourage you to check out learning more about those leaders, as I'm committing to myself. And we'd really love you to think about that. So before I hand it off to Julie, who's going to be our moderator today, I want to kind of review a few norms for this conversation. Everyone is on mute and off camera right now. So if you're wondering why you can't unmute yourself or on camera, that's why. You will not be on display at any point during this. We encourage you to use the chat box to ask some questions over the course of the session. There will be some time at the end for you to respond to. We'll flag a few questions for us, the panelists, to respond to. This is also being recorded, so we'll make that available for anyone afterwards. And I just want to remind everyone that this is a professional gathering, so we want you to stay in your best professional behavior. Remember your professional brand right now in the chat box when you ask questions and respond to things. So with that, I'm going to hand it off to Julie. Thank you so much, Julie.
Thank you so much. I'm so excited about today. I'm so excited about this conversation. So my name is Julie Samuels. I run an organization called Tech NYC. We are a nonprofit coalition. We've got about 800 members, mostly tech companies and people who invest in tech companies. And we kind of work with the city, work with the state. Sometimes we fight with the city and fight with the state a little bit. But generally, our goal is to ensure that New York is the best place to build and grow tech companies. And we think that that is happening. So my plan for the panels, I'm going to talk to you guys just for a couple minutes about some big picture stuff we're seeing in New York around tech. And then I'm going to have the panelists introduce themselves. But you guys, when you introduce yourselves, I'm also going to ask you to talk a little bit about your story, kind of how you came to be doing what you are doing and what your path to get there looked like. And then we'll, very high level and quick, and then we'll kind of dig in on some specifics. So if that sounds good, I'll quickly talk about New York and tech. The tech sector is booming in New York. It's arguably, we think, the only sector that's actually grown during COVID. Really, really big tech employers like Facebook and Amazon and Google have all signed huge new leases. They're hiring more and more people in New York. That's been going on even during COVID. And we have every reason to believe it will continue going on after COVID. And those are just the hugest employers, but tons and tons there of smaller companies as well. There are over 9,000 startups, smaller startups in New York City. And even more than that, one of the questions some of you might have, which I think is a really interesting question that I don't have a good answer for, is how do you even define what a tech company is? Increasingly, every company is a tech company. Increasingly, every company, no matter how big or how small or what they make or what they sell or what they do, needs to hire people who have STEM skills, who know how to write code, who know how to, build technical products. So we really feel bullish that the future of New York is premised on technology. And we want to make sure that all New Yorkers are getting those jobs the future jobs that are going to drive our economy in New York, in the United States, and across the world are tech jobs. And so a lot of the work we do at Tech NYC, a lot of the work I'm passionate about personally, is making sure that New Yorkers, again, have access to those jobs. So that's kind of setting the frame a little bit. I'm more than happy to dig in on any of that if there are questions. But what I'm going to go ahead and do is, like I said, ask the panelists to introduce themselves, say what you do, and if you could just for a couple minutes talk a little bit about how you got there. So Ro, why don't we start with you, and then we'll go to Tobias, and then we'll go to Jonathan.
Yeah, hi everyone, and thanks so much for having me. Also been really looking forward to this. I'll try to do the short version of how kind of I got to where I am. So first off, I'm with a company called Carmera. We are one of those 9,000 startups that Julie mentioned, based in Brooklyn, and we do basically road intelligence, but specifically we're building technology for autonomous vehicles, something called high definition maps, which these basically robots use to help them not crash into things. But there's also a lot of other applications for the kind of data that we do as a company. Can get to that later, but I can tell you I never dreamt that I would be doing that when I was starting out my career, like I think a lot of folks who are in tech. But I actually would love to actually have been in a position like I think you guys are, in terms of just how mature the industry has gotten, and maybe a little bit more on waypoints you can use to navigate. But my path was just, I'm an immigrant. I came over from India to the US when I was 4. Grew up outside Philly, suburbs there. And besides like trying to make the NBA, I really never had like a specific answer for like a normal job. The only other thing I fantasized about a little bit in high school is I would have these little ideas for inventions, and I'd tell my mom and dad, and they were very encouraging, but it always felt to me like kind of just a fantasy, and it would be so irresponsible to go and try to do that as opposed to getting a real job, right? And by the way, that might be part of the immigrant DNA, survival DNA in me. And so, yeah, basically in high school, college, I did not start out in technology after college. I joined a management consulting firm, just a fancy name for companies that other companies hire to try to, make them work better. But we were doing all kinds of projects across all kinds of industries, like retail and banking and aerospace, etc. And actually, my foray into tech actually came from a personal passion of mine, which was actually media. So I was at one point, at that point in my career, I was in my 20s, early 20s, and I had always like really been into like news and journalism and 60 Minutes and stuff like that. I thought, no, maybe that would be cool. I actually did end up joining ABC News, but the job I found was in their digital media group, and this is around 2005, and of course, digital tech, everything, that's sort of the big growth engine for any company, and media was really the first major industry that the internet especially really just turned upside down, revolutionized. And so it was no surprise the jobs were there, and that's also a good thing because that's where all the growth was happening, not so much on the broadcast side of that building that we were in. And one thing led to another, and when you join, even if you join a big company that's doing a lot in technology, big companies need small companies and startups to work with or to invest in or acquire or what have you. And so I found myself meeting with many of these startups trying to pitch Disney and ABC on working together. And at a certain point, I was like, that seems like could be pretty fun to be on that side of the table. And then that's actually, after a stint in grad school, I decided to, I came back and joined sort of a more early stage startup in technology, initially using my media experience, because that's what this startup was focused on. So sort of like a social network based on commenting around the internet. And then later I kind of got this idea, and we started Carmera about 6 years ago. But I'll pause there. I think the point is it's not a straight line, but definitely guided by personal passions and interests. And I would say the last thing I'll say is what's so great about what Jessica or Julie said is like every job is permeated with tech these days. You don't have to pick tech as an industry, even if your passion is fashion or law or something else, you can always find a tech job in those verticals. So so I think that's only good for folks like yourself. Pause.
Thanks, Rob. Tobias, why don't we go to you next, and then we'll go to Jonathan.
Hi, yeah, I'm also super excited to be here. Thanks for inviting me and having me here. So I'm a data science principal at a company called Via Transportation. It's also a startup here in New York City. What we do is we try to make public transit much more on demand. So the analogy I like to give is we try to be to bus systems what like Uber and Lyft are to taxis. So the idea is, you have an app with which you can call a bus, even if there's no bus stop. Our algorithm makes you walk a little bit to a street corner that's sort of in line with where that bus is going anyways. We pick you up, there's probably already other people on the bus, and then the bus goes not on the most direct route to your destination, but somewhat directly. And while it's going, that's picking up other people, dropping other people off, and we drop you off somewhat close to where you mean to go. And we package all this up as kind of a transit tech software package that cities can buy from us. So the idea is that the cities are our partners and our clients. There's over 150 cities by now around the world whose public transit system we reimagine this way. And you can imagine you need a lot of people who can do, write the software to do this, but also have the mathematical know-how to implement these algorithms and figure out things that might go wrong with it. And this is part of what I do, and I can talk much more about what exactly it is that I do later. How I got here is also a very, very indirect route. So when I was done with high school, all I really knew was I liked writing software, and I really loved physics. So I wanted I wanted to study physics and be on the more computational side of physics, and that's what I did. Joined pretty early on when I was in college, and then also when I went to grad school, research labs, and did research actually on biophysics, so building novel kinds of microscopes that could see things that nobody had ever seen before. But what that really helped me with was improve my knowledge of statistics, because to tease out information out of very like pixelated and kind of unclear microscopy images, you need a lot of advanced statistics and algorithms for that, and so that really helped me learn that aspect of it all. And after grad school, I actually joined another lab to do neuroscience to understand better how the inner ear works. So I always liked the interface of physics with other things, so physics with biology, but also physics with public transit. But especially in neuroscience, you solve a lot of what I guess the catchphrase or the buzzword is big data. It just means you have a data set that's really large, and it requires special algorithms and special tools to deal with, which I learned during that time. And at that time, I also became kind of upset with the subway, because I had to commute with the New York City subway to work, and the subway was always late. And I just for fun kind of tried out to model the subway system with methods that was really from my neuroscience work. So methods that we used to understand how the inner ear works. I figured out how to apply those to studying public transit. And that then in the end helped me, land a job at Via where I've been, and I'm doing similar things now. So I'm still translating all the tools I've learned over my career from physics and from neuroscience now to understanding public transit and to making public transit on demand and make it better. So you can see it's been a very convoluted route to here. So it's not it's not like I left high school and knew that I wanted to be a data scientist. And in fact, I mean, that would have been entirely impossible, since data science wasn't even really a word until I was almost done with my PhD. So it's nobody knows where the field will be at 10 years from now. So it's a very agile, I guess, agile trajectory that an agile way that you have to handle these trajectories. Yeah, I think that's it for me.
Thank you. Jonathan, why don't you talk a little bit about who you are and what you do?
All right, thanks so much, Julie. Hi, everybody. My name is Jonathan Hoster. I'm really pleased to be here. Thanks very much to the DOE CTE team for the invitation. I work at university, so a little different than Ro and Tobias. I don't actually work in the tech industry as they do. I help people get to the tech industry. So at Syracuse University, I oversee admissions for the College of Engineering and Computer Science, and I've been working in admissions at Syracuse for about, I want to say almost 14 years now. And it's really exciting getting to connect with students and their parents as they're thinking about, college options and what colleges they're looking for and what kind of majors they're looking for. We've had a really great STEM college fair in New York City for a couple years. Didn't happen last year, of course, but hopefully will happen again soon. But there's a virtual STEM fair that's coming up on March 7th. That's going to be sponsored by the National Association for College Admission Counseling that I've been helping put together. So I'm going to put a link here in the chat for that. So we definitely encourage you to sign up for that affair. There's going to be over 200 colleges there. I see Penelope asked, where is Syracuse? So I should explain that. I appreciate that, Penelope. So Syracuse is Syracuse University is located in Syracuse, New York, which is, I consider upstate, but my friends from Potsdam don't consider Syracuse to be upstate. So that's a relative term, but we're basically in the geographic center of New York State. So I know all of you are in New York City. So driving time is probably about 4 hours from New York City to Syracuse. And we have a lot of students from New York City, and it's very easy to get here. Some people take the train or take the bus, so very easy to get to Syracuse. We have about 15,000 students, including about 1,300 that are in engineering and computer science majors. So my interest in this field and the discussion about careers in tech and STEM education is because of my role at Syracuse University and connecting high school students to our majors in computer science and engineering. And I was also a first generation college student myself, so I'm always particularly interested in helping open up doors to other students who are going to be in the first in their family to go to college. And once you have a degree, one of the coolest things I think about degrees in these areas in tech and computer science and engineering is once you have that degree, it means you're an analytical thinker and you're a problem solver, and those kind of skills are applicable in such a wide range of fields. And so I'm definitely biased because I work with people in STEM all the time, but I think these are really great careers to get into and can lead you to a lot of great possibilities. So I look forward to hearing your questions and participating today. So back to Julie.
All right, thanks, guys. Okay, so I want to quickly talk a little bit about pathways into these types of jobs. And I think you all I'm glad that you're all here because you sit in a different kind of piece of the ecosystem, if you will. So Jonathan, I want to go back to you. And I've been looking at the chat a little bit and I'm getting ahead of myself, but it seems like there are some questions about what types of degrees are out there. So I don't know, without going into like the full catalog of Syracuse degree granting programs, maybe you can break down like a couple of the kind of categories of STEM degrees and how students can and should think about that as they approach going on to post-secondary school.
Sure, absolutely. I mean, there is really, as you suggested, such a wide range of fields that students can get into. When we talk about STEM, I mean, that's only 4 letters, but it's hundreds of degree pathways probably. So, so I work particularly, as I said, in the Engineering and Computer Science College at Syracuse. So just with one of those degrees, you can go into so many different areas. You know, and if I think about just our alumni who work in New York City, I mean, we have people working at tech companies and banks in New York City, at Google and JP Morgan and many different startups. And we have people working for the MTA. I saw somebody comment about the subway earlier. I mean, we have some civil engineering grads who work for Metro North. So if you've taken the train, Metro North train, you know, they do that. So there's so many great careers you can get into. I saw somebody asked earlier about physics, and physics is, I would say, really important in a lot of, maybe not every single one, but in a lot of tech careers, I think having a background in physics is definitely important. But there are a lot of ways to get into tech careers too. And I think it's important to think about like the accessibility of these programs. So to Julie's point, in terms of the variety of options we have just at one university, at Syracuse University, that we have a program called Information Studies, which is also a way to study the intersection of business and technology, and also get into tech careers that way too. And we have a number of people who do that. So a university like Syracuse is made up of individual colleges. So we have a College of Information Studies, we have a College of Engineering and Computer Science, and sometimes our students mix and match, like major in one and minor in another. So any of these degrees can lead to lots of great opportunities, as can degrees in the traditional sciences, in physics, in biology, in chemistry, in biotechnology, in neuroscience. And a lot of students at our school will do double majors and majors and minors as well. And they do research as well with professors. And that's a way that students really get a sense of, what they like to do. But yeah.
Well, and it sounds, Tobias, like that was kind of your path, right? You picked, like you said at the beginning, you picked the subject that you found the most interesting, and you never thought you would have ended up in this job, right?
I think that's right, but I think largely because I think I knew early on that I really liked solving difficult tech problems using methods from a variety of hard sciences. There was just no word for that job, right? Like data science hadn't been invented, so that job just didn't exist. So I think these days, I think it's, since that job exists, it's maybe a little bit easier to figure that out. But I do think that from what I've seen, at least that the typical path, at least into like a data science position, seems to be that route. So just, on my team, there's 6 data scientists, and 4 of them, have PhDs in a variety of fields that, don't sound like data science. So there's a biologist, so PhD biologist, PhD economist, and so one woman is joining. She has a PhD in I think it's operations research, and so it's, you can make it into data science from as long as, I think, from a quantitative science, I would say that's I think the typical path.
Ro, as someone who thinks a lot about hiring and actually building a team, I was hoping you could talk a little bit about what you look for at the early stages and as you grow, and how you think about degrees, and how you kind of think about how you pull the pieces together.
Yeah, well, look, first off, just purely supply and demand. There is a perpetual shortage of great people generally, but especially technologists, every year, every month, every week. And that's great if you're on the, on the hiree side. It makes it hard on the hiring side. And what that means is, and especially in technology, is, you have to, remember, companies like Carmera, we're competing against Google and Facebook and those companies for the same people a lot of the time. And one thing that's helpful is if you have, something that's interesting problem and, a really strong mission and the opportunity for impact, and you find people, one of the things we're looking for are people whose juices get flowing by that, because it gives us an advantage to convince those people to come to us instead of some of those bigger companies. But then also B, it just sort of shows us like those people stay a long time, and they get really involved in all parts of the company. And so I would say just generally one thing, like, I know there's a lot of talk about what major should I do or what industry. Like I think the one thing that really has to show through is just passion and geekery, right? And that, because it really does, whether it's in a resume or a GitHub repo, some of you guys are software people, or your personal website, or in an actual in-person interview, that is going to shine through. That is what people like me look for. That's also, by the way, what the bigger companies look for too. And the other thing that I very much look for is, yes, like we have folks who've gone to name brand schools or work for big name brand companies. But we've also have a lot of people, for example, who are like, humanities majors and now are some of our best programmers. And that happens all the time. We've probably had people who didn't even go to college. So the nice thing about tech is you know, it certainly has plenty of its problems on, you know, on certain skews and biases. However, in terms of compared to other industries, it is much more meritocratic, and you know, you tend to be able to level the playing field by just showing the output of what you can do, as opposed to just coming from a fancy school or having, you know, presenting really well in an interview. And I think that's any opportunities, even if it's a little side projects that someone did, you know, for a summer or a few weeks, and you know, they have, it's either they describe it in the resume and it's really cool, and you know, you could tell they're kind of gritty and they hustled and they're creative. That goes a long way too, because like the scrappiness and the self-starter aspect of things is just absolutely sticks out, and it's something we all always look for. And by the way, this is a perfect time to plug a new program we just started last week at Carmera. So we have full-time hires you guys can check out on our website and all the usual stuff, but we recognize this, like, that there is an opportunity for us to play a more proactive role in making those opportunities available to people if they're interested in a company like us. So we created this thing we call projectships. It's just like a hokey little term for not quite an internship that you would think of for a full summer, but more like a 6-week sprint, which is paid, which is very much doing meaningful work for a part of our company and business that really matters. But you know, it's a very fairly low friction way for both company and someone early in their career to, you know, get some of those swings at the plate, so to speak, and you know, not only get the experience from it, but also get someone excited that they have that on their resume. They can talk about it, because you know, maybe I'm going to be looking to hire you for a long-term position, and that would really resonate to me, that you know, you took on that opportunity, even if it's, like I said, even if it's only 6 weeks, you know, in one springtime quarter. So I'll stop there, but those are a couple of sort of qualitative things that really matter to us in hiring.
I'm really glad you talked about that program, and it's so great. We're so glad you're doing that. And one of the things that got me thinking about it.
I'll be,
yep.
They'll kill me if I don't share the URL, carmera.com.
Yeah, put it in the chat.
Join. Okay. Oh, great. Thank you.
Put it in the chat for everyone.
Yeah,
yes. So Jonathan, I want to kind of bounce off that and talk a little bit about what high school students can be doing to prepare to go, you know, to study STEM fields at college. And then I'm going to go back to Ro and Tobias to talk a little bit more too about what, you know, students at the high school level can be doing, like with the Carmera, these, I'm sorry, they're not internships, they're project sprints.
We call them project ships. It's never going to stick. We'll try.
Yeah, that's great. Okay, so Jonathan, if you could talk a little bit about what students can be doing now to prepare for college, and then we're also going to talk about what students can be doing now to be thinking beyond college and thinking to what getting jobs can look like. So let's put these kids to work. You're not kids. Let's put these students to work. Let's give them some ideas.
Sure, absolutely. So if you're excited about opportunities to work for really cool companies like Carmera and Via Transportation that you're hearing about, then what you should do to prepare in high school, I would say math is one of the most important things, but math and science both. So if you have the opportunity to take up through pre-calculus when you're in high school, I would say that's important. When we're looking at students that want to go into science and computer science and engineering majors in college, we really want them to have at least pre-calculus in high school. So if you're in 9th, 10th, or 11th grade right now, you can work with your math teacher or your school counselor to sort of plan that out. So you'll be in pre-calculus by the time you're a senior. I think that would be great. Those of you who are on the path to take pre-calculus when you're a junior and you have the opportunity to take calculus as a senior, then that's really great too. In terms of science, I know we talked a little bit about physics earlier. I think physics is important for sure as we're thinking about these careers. So if your school offers physics, then you should plan to take physics while you're in high school. I do know that there are some smaller high schools in New York City that don't offer physics. So in that case, I would say talk to your teachers and your school counselors to see if there's a way you could take it through a College Now program, through a CUNY while you're in high school. But at the same time, I will say that those of us that work in college admissions aren't going to hold it against you, you know, if you didn't take a class that was not offered to you. So, but as you have the ability to kind of think ahead about your high school experience, that would be a good thing to have under your belt. And I know somebody had asked earlier in the chat about computing courses and coding courses, and is it required to have those in order to go into these majors in college? It's not required to have that experience in high school. Now, if you're especially at a CTE school that offers those kind of things and offers some courses in coding or computer science or whatnot, then absolutely you should take those. It's a great way for you to get a sense as a student if this is something that you like to do. And then certainly that's going to prepare you to do well in these kind of fields in college. But I also want to say that if your school doesn't offer those kind of things, or maybe you're a senior now and haven't had the chance to do that, that's okay. Like, you can still go into a computing and tech major in college and you'll be perfectly fine, because we don't, at the college level, we don't assume that students have that background. Like, we start from the beginning with their intro programming classes.
Tobias, I would love if you could talk a little bit too about what kinds of things you think high school students should be thinking about, what they could be doing now if they do want to explore careers in the tech sector.
Yeah. So I'm not sure how broadly to all of tech this is applicable, but if you think more of maybe going into a career where you do the science behind the tech, I think what's really important is next to calculus also statistics. And I wish someone had taught me this while I was in high school, because I didn't necessarily give as much credit to the statistics courses I could have taken as I did to calculus and so on. And so I had to learn statistics later when I actually needed it to analyze experiments and so on. So I think my biggest piece of advice would be that as you do some science major, and I really don't think it matters too much which one, just what interests you most. But I think what is important is when you have the chance to take an elective statistics class, to not pass on it and to take it. And I think the same thing for coding classes, and because it's much of data science and much of tech is to use, when you hear these buzzwords of big data, so it's all or machine learning, so it's all really just fancy terms for statistics, and it's really important to have a really solid foundation for it, because the fancy algorithms aren't very hard if you understand the basics. And so the earlier in life you learn the basics, the better, I think, just in terms of getting intuition for statistics, I guess. So I think that's,
I would just echo that. I think that's so right. Like, all these fancy terms are really just fancy words for statistics. Yeah. And I also just think, even if you don't want to go into, software engineering or something like that, it's just, I just feel even in the last year with the pandemic, hearing about efficacy rates and in this group and this, like thinking about risk, and like, actually humans aren't that wired that well typically to think about probabilities and statistics. And so actually doing formal like training on that, I think is just a really useful life skill.
I have two questions that I want. I'm not sure who's best to answer them, actually. I'm kind of, some stuff you guys have said, and I've been looking at the chat a little bit. One, can one of you explain artificial intelligence and machine learning, not super in depth, but just a little bit better, just to make sure we all know we're talking about the same thing? Because I'll just say too, we survey a lot of tech companies in New York about what types of jobs they think they're planning to hire for in the next few years. And everyone's hiring more people in AI. And the thing about AI is it's kind of a vague term, and it captures a lot of things. So I was hoping, I don't know, Tobias or Ro, it's probably, well, I don't know, or Jonathan, whoever wants to weigh in and talk just a little bit about like what is artificial intelligence? Like, what does that even mean? I think that would be useful.
Yeah, maybe we can tag team it a little bit. I can kick it off, and then we can fill in the gaps, I think, between each other. So I think so. So I think the very basic of AI is just that. So I don't know how much I guess calculus everyone has already taken, but if you think about just a complicated function, a function that has so if you just think of a graph, you have an x-axis and a y-axis, and you have some complicated shape. You can imagine, for example, that graph tells you, I don't know, the number of accidents in New York, right? So the time axis would just be days, and so x-axis would just be days of the month, and the y-axis are the number of accidents. And now you're trying to put, and you have all these dots in there, right? So it might go up on some days, it might go down, the number of accidents might go down on other days, and you're trying to put a line through there. And if you can find a way to compute a line that captures the underlying cause of this, right? So it might be raining on some days, which might increase the accidents, or there might be particularly much construction on other days, which might have an impact. So if you can capture all this and you can actually find a way to model this line that should go on there, then you can start making predictions, right? Because you can now look into the future and say, well, we haven't measured yet what the number of accidents will be in the future, but we can extrapolate this line that we've already fitted through the data that we have. And making these predictions, that's all really AI does. So finding a model that you can use so you validate it on the past, right? So you make a model, you say it depends on the weather and on construction, and maybe on whether it's a holiday or not, and lots of factors like that. You make a model, you validate it, you see whether it matches the data you've already recorded, and then you can use it to make predictions about the future. And all that an artificial intelligence then does is just make the model bigger and more complicated, and so it takes in much more inputs than the four things we just, like, the weather and whatever I just said, and the machine that combines them all is more complicated, but in the end it's the same thing and just makes predictions at the end based on that. So I think that would be, and I think the complicated part you have to learn, and the complicated part that has to do with statistics, is how do you build the machine, and how do you make sure the machine matches the past, but doesn't match the past so overly well that it's predicting noise that is not really underlying the true data. So you only want to capture true effects, right? Not just random spikes in traffic accidents in New York. Yeah, so that would be my first pass at this.
That was great. Ro, maybe if you could bounce off for that for a second and talk about why being able to make those predictions is so important in business and for companies, like how that plays out when we implement it into real world. And I have to quickly say, Tobias, I've been working on this stuff for a long time, and that explanation was that was really solid for putting you on the spot. I'm super impressed.
Totally. Yeah, I mean, it is. Well, I think, the other way also, I think about the answer to that question is comparing it to what for decades we've thought about as computer science or programming, which is basically you're entering in a bunch of rules for a computer to follow, and then you're telling it what to do, and it goes and does it based on those rules, and usually does it at millions of times per second or whatever. And that's great. That's the foundation. That's also the first thing Tobias said, is get experience on that. But then what I like about this is it actually follows Tobias's two recommendations. It's like, that sort of foundational rules-based computer programming. But what most people think of as AI is that second piece, which is much more based in just statistics and looking at just sort of what happens randomly in life, or maybe not so randomly, and then trying to model something out of that. That is not someone saying, hey, this is just writing a bunch of rules. That is someone actually trying to teach instead of tell something to a machine, right? And meaning it's just, AI is basically saying, show lots and lots of examples of something that's happened, some pattern, and let that machine learn until it starts figuring it out and sees the same pattern and can get so good at it that it starts predicting and getting those predictions right. And so the prediction, to answer your question, Julie, that's like what so much of the problems we're all trying to solve, and the business, where the revenue is for companies. In our case, it's helping robot cars make better predictions on where to go next, essentially, and in the safest, best experience for the passenger. And in our case, we're actually feeding what's something called priors, but basically it's like feeding knowledge that's already known about the world to make the prediction better. But again, that prediction is based on having seen thousands and millions of situations of that right-hand turn, right? But now when you got to make that right-hand turn, that's where the so-called AI technology is just doing it based on what the machine's learned, as opposed to what you've necessarily just programmed it to do at every right-hand turn. And that's why it's just changed everything. It's sort of added this duality to to technology and software engineering, where you have to kind of choose typically a mixture of both of those things. But certainly the AI part of it has just exploded in the last 10 years.
I have to say, I bet this is the only panel that's talked about robot cars. So do we win? Or do we? Yes, good. Thank you. Okay, I want to make sure that we have time to get to questions, but Ro, you brought up something else that I'd seen come up a few times, and it's something I just quickly wanted to comment on. It can be, if you guys want to expound on this too, you surely know a lot more than I do. But one of the really interesting things about tech jobs, to my mind, is that there's a pretty wide spectrum. I mean, a huge spectrum of the types of jobs. And you can, like Tobias, have a PhD and have a, deep kind of computer science, data engineering, like, deep understanding of these things, or you can be someone who knows how to code, right, and helps build websites, which those two things are totally different things, right? I mean, maybe one of you guys can talk about that a little bit better than I can, but one thing I really hope that all of you guys who are listening can take away is that there are tons of kinds of jobs, and some do require deep understandings of statistics and mathematical concepts and certain scientific concepts, and some don't, right? I don't know if anyone wants to weigh in on that, but I think that's a really important piece of what I hope you all kind of take away from today's discussion.
I mean, that's definitely true at VIA. I mean, there's tons of people who are not data scientists at VIA. So with everything from like operations teams to legal and sales. So there's and of course we have like this software engineers, and yeah, like, so there's plenty of jobs for which you don't need to understand the statistics that underlie it. I was just talking about it a lot because that's where I came from. But
no, and that's what I'm here for. But I mean, I've been working in tech for over for, I don't want you all to know how old I am, but for a long time, and I don't have a technical background at all. I used to be a lawyer. There are a lot. Ro, do you have a technical background?
Somewhat. I mean, I was in engineering in college, but never a practicing one. So I'm a fake engineer, I guess. I was always on the business side after college. But yeah, I mean, that's actually a good. I was going to make a point on that, which is absolutely you're correct, Julie. There are, as I said, there's just a lot of demand for good people, regardless of whether they're practicing technologists in the traditional sense of writing code or something like that, or if they are on business operations, et cetera, roles. But what I would still say across all of them, all of our biz ops folks, for example, at Carmera, both of those two things that I mentioned at the top were very much front and center. One is the passion of the problem and kind of using technology to solve the problems that we're going after. And two is you could always still see that they did speak the language, they'd done their homework, they'd had some relevance in their background. Like, I'll put our VP of business development, who Julie also knows, on the spot a little bit. Jessie, who actually she used to be one of the biggest allies of DOE back when she used to be the chief digital officer of New York City. But she came from a policy background. She worked on presidential campaigns. And but A, the passion was there in spades, and B, she had done a lot to expose herself to very technical experiences. Part of the time when she was in City Hall, for example, she was a key part of Computer CS for All initiative and a bunch of other initiatives. And also she did an internship during grad school where she was exposed to a lot of what's called frontier technologies through a a job she found at GE. So meaning like, 3D printing and space and all that kind of stuff. So I think I would say definitely there's a lot of non-actual engineering jobs that are out there, but I still think speaking the language and showing some experiences here and there do go a long way.
Okay, I've gone over actually. I was supposed to save more time for questions than I did. So I hope I'm not in trouble. But maybe now we should look to the, Jessica, you want to help me kind of pick out some questions from the chat here?
Yeah, there are so many, but I'm actually going to ask my colleague Murph to join us. Murph is on the New York City Department of Education's College and Career Planning team. And there have been so many questions sort of along the lines of, what do I do if I don't know what I'm interested in pursuing? And want to make sure that all the students on the call hear about the resources that Murph has at his hand, so you can be better informed about decision making. Go ahead, Murph.
Hey, thanks. And holy smokes, thanks to all the panelists. This has been such an awesome education on sort of the inside job of so much of the stuff that just surrounds us in our daily life and that we interact with all the time. It's just fun to hang out with smart people. I'm looking forward to the smart questions from the chat, so I'll be real quick here. I think actually Jonathan's answer to Kate earlier on in the chat about, hey, what's the value of a sort of a famous tech school degree when it comes to getting a job? Jonathan's answer to that was both answering that question, but also in a way that I think is really instructive for the way that you can think about your college and career planning in general, which is every school can be the exact right school for any student. The trick in making your plan is thinking through what is the right school for you. And the questions that are embedded in that are ones that you want to talk through with your family, with your friends, and with your college counselor, your guidance counselor, really any adult, right? Like the panelists here even have had a lot of insights in that regard. But the things that you want to think about are affordability. Like debt is just an absolute monster that you want to be really careful of when you're thinking about where you want to go. There's huge payoff in some careers, but there's also a lot of risk in the loan practices and the viability of like, where will you graduate and where will you succeed that can affect your debt and your income for a long time. So you want to be really intentional about the affordability questions of like FAFSA and scholarships and sort of what's the price tag at a university. And then you want to think about the experiences that you're going to have on campus, like where you'll feel a rewarding experience, where you'll feel belonging, membership, and success as a part of the academic community and the interpersonal community that's there, so that you really feel like that school is your school where you go, just like you'll want that job one day to feel like your job and your career path and really stay invested there. All that stuff is so highly personalized, like things like the name of a school matter for like name recognition, but things like the network that you build while you're at school matter for your long-term success. But really bottom line is like deciding for yourself based off of all of that information, what's your best guess of where you can go, and your college counselor can help with that a ton. My team, the College and Career Planning team, so the last thing I'll say, I'll just throw a resource in the chat to help with this, held a series of panels kind of just like this one last summer for rising seniors that I think is still relevant to anybody on the call that is a senior now or anybody that's a junior, which really kind of takes into account a lot of the things that I was just naming: affordability, match, belonging, how to talk to your family, all those things. So there's a bunch of both pre-recorded sessions and then kind of workbooks that you can use to think through a lot of that process.
Can I build on that for one quick second? You know, one thing I'd say too, that no matter where you decide to go, whether it's in New York City, whether it's in Syracuse, New York, or, you know, somewhere you have to get on an airplane and fly to even, one thing you really have going for you that is quite lucky is that you're from New York City, and there are thousands and thousands of companies in New York City who are working in tech, like I said at the outset. And if you can, for instance, like the project ships that Ro talked about at Carmera, or if you can take advantage, if you're home for winter break, if you're home for summer break, there are a lot of interesting programs all across the city that are helping students in New York City find different kinds of internships. There are even if you need to work and be making money, there's a program called Whitney, for instance, that's through CUNY for women in tech. And Whitney works with students who are also working while in school, and works to find internships for them that like fit in those schedules. And so a lot of people aren't from New York. A lot of people don't live in a city where they can access companies that have opportunities for internships, for building relationships, for building your network. And I would recommend, it's a little complicated because there's not like a single website you can go to find all these opportunities, but you can reach out at Tech NYC and we can try and help you find companies. We were very active with Summer Bridge. We used to be called Summer Youth Employment, where we helped hundreds of students who did the Summer Bridge program this year get participate in projects at tech companies across the city. There are a lot of things like that happening, and you should really take advantage of being, super lucky that you're a New Yorker, which is the best kind of person to be anyway.
Okay, so there were a lot of questions about terminology, and I don't think we have enough time to get the specific answers. So people are asking the difference between engineering and engineering technology. Jonathan, I saw you respond to that. Programming versus software engineering, computer science versus computer programming. Does anyone have any thoughts about like I think Ro, you had mentioned earlier on about like sometimes there's a lot of jargon out there and it's hard to, sometimes it can be as simple as just breaking it down to one term. What can you share with students about who are confused or want to learn more about all these terms that fall underneath the umbrella of technology?
Everyone's confused and basically they're pretty meaningless distinctions. There just happen to be, whatever the fashionable term is of the decade. So, it used to be programmers, coders. Sometimes it's a bad word to say that. Sometimes it's not. So I think these days, probably most often you see engineers or software engineers. Well, I guess engineers in the broad term, whether that's software or hardware or whatever used. But they're more or less the same, really. That's my take, at least.
Got it. And then we had another kind of more overarching question. I'd love to hear anyone on the call respond to this one about like, what's the most challenging aspect of your job?
That's a really good question.
Yeah. I think in many cases, for me right now, I mean, I think it changes, of course, but currently it is to find the data, because you can imagine we log like there's a lot of data, right? Like every bus that we route sends a GPS ping, like every once in a while, and we know where it is, and now you can compute so many different things based on that, and other people, other people may have already done it, on the team, and it's logged somewhere. So and I think this is like generally true for most. I think for most tech companies that were friends, it's generally there's these big data problems are like a big problem of them is just to figure out what the correct data to use is and where it is, and then to get it in a clean way out of the database. So I think that's often a hard question. That's maybe not it's maybe not the answer that people were looking for, but that is a big challenge in terms of I guess this like technical things. It's of course an ongoing challenge to stay on top of novel statistics as they get published, right? So there's the field is really hot, and there's a lot of new methods that get invented constantly, and you kind of have to make an effort to stay on top of things and to constantly learn. So I think those two things I would say for me at least.
Yeah, I think I'd riff off something you said, which is two things. One is the world is messy. A lot of people think technology, you write code and it just elegantly solves all the problems. It never does. And there's always weird little exceptions and edge cases. But you just got to get comfortable with that. And the other thing you got to get comfortable with is technology is, by definition, you're entering very unpredictable, fields because you're either on totally new ground or you're dealing with things that don't really move in a straight line. They may move like this and all of a sudden like that, or they move, they move in curves that we're not hardwired to think about. So I think you need to be really comfortable with both of that messiness and that what I'll call nonlinearity, a fancy term of, but actually embrace it and like it.
Yeah, we hear that so much from other tech industry partners, that you just have to be a lifelong learner. Just be prepared to keep knowing that you're going to continue to have to self-educate yourself about what the trends are and what the technology and the programs are. So I think that's about it. Julie, do you want to close us out?
I just want to say thank you so much for everyone, for the panelists, for taking the time, for these great questions we had in the chat. And just the last thing I would say is the first thing I said, and it's that these jobs are not just the jobs of the future, because there are so many of them, but they're also the people who are building the technical tools, are building like all the things we use and live in. I mean, think about how much technology touches your lives. And it's such an amazing opportunity to help build that stuff. And I think you guys should all get jobs in tech, or everyone who wants to should try, because it's a dynamic and interesting field. And sometimes it's hard and sometimes I'm exhausted, but I'm never bored.
All right, we'll leave it at that. Thank you, everyone. We'll be following up with an email with the recording. See everybody soon. Bye-bye.
Bye-bye.